theoretically, small intestines thought they would only secrete mucus for lubrication and protection, and there would be no absorbents, and everything has been digested already. So basically, the only thing that would really be absorbed was mostly water and maybe some minerals. And so by the time you get to the end of your large intestines, it'd be in your rectum, it'd be solid feces, right? That was a classical way of thinking about the large intestines. That has radically changed, and it's radically changed recently. And we'll talk about a little bit about it towards the end of the lecture. And the reason is it's because of the gut microbiota. It's being really hailed as the hidden organ of the body. It's basically, there's a whole community of gut, basically microorganisms in your large intestines that do a whole bunch of work. And we're just learning about how much work they do with you as an organism. There's a lot of symbiosis between the bacteria in your large intestines and your body. They do. That's why there's question marks, because a lot of things that you don't digest, they get to digest. For example, cellulose. That's the material of plants. Those are polysaccharides. We don't have the enzymes to break down cellulose. Cellulose is another word for fiber, basically. We don't actually break down fiber, but bacteria can. And so they can break down cellulose, and they give us lactate. And we can actually absorb that lactate. So the byproduct of their digestion, we can absorb. And that's why there's a question mark at digestion, there's a question mark at absorbance, and there's a question mark for secretion too, because we're just breaking the surface here in the research. There is actually a lot of crosstalk between our autoimmune system with the microbiome here. There's some speculation that they actually put a lot of hormones or pseudo-hormones that actually go into our bloodstream, can affect even our brain. So there's a lot of question marks here. And this is really a 21st century science. If you want to be on the cutting edge of medicine, this is it. That and neuroscience, but who cares about neurons? Alright, so where am I at? Alright, so we're into the cephalic phase, and then we're going to call it quits for today. We'll call it quits a little early today. So, let's draw some food. Let's draw a little steak here. There's our T-bone steak here. It's kind of small, but we're on a budget. So, with sight, through smell, sometimes even hearing, it works. You can get these anticipatory reactions to food. You can get these anticipatory reactions to getting ready to eat food. So you smell food, you drive by a Taco Bell or something like that, and those bastards vent out sideways. Have you ever heard of that? Fast foods, when they make vents, they point them out sideways, not up. You think it goes up into the sky. No, it goes sideways, so whatever they're cooking goes out into the environment, to the sides. When you drive by, you smell it. That's all intentional. That's why. So you drive by a Taco Bell, you smell it, and you're like, oh man, it smells really good. And yes, it does. End of discussion. And so you actually will see, you see reactions. Your mouth starts watering, right? You've heard that thing where your mouth starts watering when you smell food, when you see food. That is an anticipatory reaction, right? That is your body getting ready to digest food. And so what does it mean? That could mean a lot of different things. That could mean this anticipatory reaction of producing saliva. This anticipatory reaction of producing acids, other hormones that trigger other digestive processes. It actually can go pretty far down the chain. And this is all relates to your central nervous system, associating sight, smell, and even sounds to food. So this is all part of this anticipatory reaction. And then this is all parasympathetic responses. I said this class is not directly cumulative, but the autonomic system comes back time and time and time again. And so you need to know, you really need to know your autonomic system. You gotta know what's sympathetic, you gotta know what's parasympathetic and what they innervate. And so digestion is pretty much all parasympathetic, right? You're not gonna worry about digesting food when you're running away from a tiger. And so this is all parasympathetic response. So we have a whole bunch of saliva glands here that produce saliva and kind of dump it into our mouth. And so what happens is, once that food actually makes it into our mouth, we then get taste. Can't spell taste apparently. And that can even further other anticipatory reactions when you taste food. There is a wavering theory about you tasting foods and you hungering for several types of food. It hasn't really been proven with great success, but the idea is if your body's fat deficient or carbohydrate deficient, it will have you hunger for certain types of food or hunger for, fatty foods or sugary foods or things like that. There's even supposedly these kind of taste buds along your GI tract, like in your small intestines, that can sample. Oh, but this is a very fatty. Fatty chyme, so we're going to produce a lot of lipases down later on, let's say in the jejunum or the duodenum or something like that. And so taste is actually a very interesting kind of receptor in the GI tract. Like I said, it's kind of a iffy hypothesis that still hasn't been fully proven yet. But yeah, this taste also creating further reactions or demands. But once it's in your mouth, the main thing is mastication. Can't spell mastication. Mastication, that's just chewing. That's just the technical term for chewing. And so the whole point of mastication actually serves a little bit as a form of motility too, because you're mixing. You're not only just kind of chomping and dicing your food, you're mixing it around. You're having that saliva mix well with whatever is in your mouth. And when you're done chewing your food, you swallow. And so that's the next part of the cephalic phase, is swallowing. And by the time when you swallow, it is now considered a bolus. That's what we have here, bolus. And so I know there's a lot of terms here. Don't have to worry about all of them. But basically the idea here is the tongue, when you want to swallow, will take your food and push it back into your mouth. What it hits here is this piece called the soft palate. It's a part of tissue that comes off your hard palate, right here. And then when it hits this soft palate, it triggers a whole bunch of things. It triggers the swallowing reflex. And what happens in the swallowing reflex is your epiglottis right here kind of points up, kind of catches the food as it goes down the esophagus. And then what's going to happen is this, with the help of your tongue and the soft palate, your food's going to move down, and the epiglottis is going to help kind of cover your trachea. And so the two main parts here are the soft palate and the epiglottis. The soft palate helps food from coming out of your nose, right? It's all one cavity, right? If you didn't have your epiglottis, you would kind of suffocate if some food got stuck up in your nasal cavity, right? And then you would sneeze it out, and then that'd be nasty, right? You don't want to do that, right? And so the soft palate there is to help block food from going upward. And then the epiglottis here, this guy right here, is meant to basically prevent food from going into your lungs, into the trachea and the bronchi and whatnot, because if you don't want food there, that's going to block airways. And so that's why the epiglottis is there. That's why whenever you swallow, you can kind of feel some movement in your larynx right here, to the epiglottis closing over your trachea and moving back up as the bolus moves down your esophagus. Now, this can screw up. Everyone's choked on their food every once in a while, or choked on water. It's not like a foolproof mechanism, but it works most of the time. And then what happens once it gets past the tracheum, Then it's all about peristalsis. Peristalsis is then just gonna, using those waves of contraction of smooth muscle, will then kind of push it all the way down into your stomach right here. And so that's where we're gonna stop for today. One thing before you go. So I'm breaking down the digestion stuff into 2 more lectures. It's probably not going to take 2 lectures, so I'm going to spread it out. So what will happen is there going to be some free time towards the end, which I'm going to use for review. So instead of just sitting here and asking you, what do you guys want me to review? You guys email me things you want me to review, or you can just send me a message via Canvas, and then I'll take time at the end of those classes to review that material. So email me your review topics, and we'll review it over the next couple of weeks. I'm going to try something new, see how well it works. And yeah, that's it.